So for the final two examples here, one of them is looks a little simpler than others, but we're going to come to this one at the end just to demonstrate a certain fact about material equivalence here. So let's go ahead, and actually both of them involve at some point material equivalence, because in each case we have these tribar statements. So in general, you know, if you see this in a proof, it's probably most likely a good indication that it's somewhere along the road you're going to need to do material equivalence on that line. Not always, but especially if it's like, I don't know, embedded in a conditional statement where maybe you would use a rule of implication like you know, modus ponens or modus tollens, maybe you wouldn't have to use equivalence, but a lot of times you do. So let's begin with this one here. The third one here that we'll mention. So let's look at this one. So we're trying to get a not R. Well, we know here that there's an R on line 2 and there's an R on line 1. And so we might be deriving R's from one of these two lines, or maybe we need both in order to do it. My suggestion here is that given that this biconditional is not embedded within any sort of conditional, or you know, any other sort of compound statement like a conjunction or a disjunction, my suggestion would be to begin by using the rule of equivalence on line 1 in order to kind of flesh out this biconditional statement. So the question then becomes, what do you want out of this? What kind of conversion do you want with equivalence here? Because again, there are two forms of equivalence. There's different ways of doing it. So one could be either the conjunctive statement, or the other one could be which involves, you know, the conditionals, or the one that involves the conjuncts, the disjunction of the conjuncts here. So somewhere along the line, we're going to need to get that R out of the way here. So the thing I would suggest is to just try first by doing the conjunction that involves the conditional statements on line for equivalence here. So on line 1, using the rule of equivalence, let's go ahead and say K horseshoe R and R horseshoe K. Right, so that sort of puts that out here. Get that line out of the way. Okay. The next thing that we'll want to do here, again, this is sort of looking at what we want out of all of this. So again, to kind of backtrack a little bit here. So if you could get this where, basically, you could use this not P and use modus tollens to derive a not R. That would be what we would want in the end, but we need to get rid of this K in some sort of capacity here. Eventually, what we would like to do here is it would be optimal if we could just get rid of the K by canceling the K's out in a certain capacity. Alright, so if we're looking at what we have, well, if you're looking at line 4 here, you can't really do anything with the first conjunct here, K horseshoe R. It's on the same side, it doesn't work. But if we could get this conjunct out, we could do hypothetical syllogism and get rid of the K's altogether. Now again, in order to do simplification on this, we can't just simplify out that second conjunct. We have to switch it around, and using the rule of commutativity. So on line 4, using com, we'll switch these. So we'll go R horseshoe K and K horseshoe R. All right. And now we can simplify out R horseshoe K using line 5 and the rule of simplification. Okay? Alright, so now we have the K's on the opposite sides of the horseshoe, so we can go ahead and do on lines 2 and 6, we can do hypothetical syllogism. So the K's drop out, and now we're left with this, R horseshoe R, horseshoe P. Right. So so now we're kind of left with this sort of funny statement here on line 7, and again we can't quite use that not P yet because again it's going to have to involve some sort of rule of implication, and we can't use the rules of implication on parts of statements. We would use them on the whole. So somehow or another we've got to get rid of these R's, and it's kind of weird that there are these two exact statements basically together. So how could we get this out of the way? Well, if we could use the rule of tautology, which just basically states that if you have the disjunct or the conjunct of the same exact statement, it just boils down to the statement by itself, we could get rid of the R and basically have just one R there. Okay? Not get rid of it, but just reduce it down to one. So the rule that will allow us to do that then, to go back to your rules of replacement, is exportation here. So using R and using that rule, we can derive, so this is on line 7, I should say, EXP, and then that sort of, again, that's that rule basically that says if you have the conjunction in an antecedent, it's basically like saying you have two antecedents, because you do. So then we can convert that to R and R, horseshoe P, okay? Right? And now we're left with lines 3 and 8. Well, before we get to that point, we have a redundancy here, so we know that R and R, if we use on line 8 the rule of tautology, we know that that just is basically just is equivalent to R, and then we have our R horseshoe P, and I'm going to go over here real quick just so we have enough space. So on step 10, okay, now we have 3 and 9, and now we can just use that general rule of implication of modus tollens because we have the negation of the consequent, and so we can, by that rule, by lines 3 and 9, using the rule of modus tollens, derive not R. And there it is. Again, a lot of this is sort of kind of working your way backwards here. So obviously the trickiest part here is knowing which way you want to convert the biconditional, and it seems like given the fact that you have all of these conditional statements, you probably want to stick with the conversion that will have the conditional statements in it. So some of this maybe is a little bit of trial and error in the end. So just sort of keep that in mind as you sort of work through these here. So the final one here is a lot more simple than this. And basically what we have here is a conclusion in which the conclusion is a biconditional. So whenever you're faced with that, unless you have the biconditional somewhere in one of these statements, you know, like it actually is A, tribar D, somewhere in here, most likely you're going to have to, in the end, your last step is going to have to be the rule of equivalence here. All right. So if you're looking at this, now again, there's two ways of converting it, but given the one conversion that has all the conditionals, you would know that this is basically saying A horseshoe D and D horseshoe A. That's the equivalent here. So you're looking for that within the premises. Now that's a little easier to see because, okay, right away we have this disjunct on line 2, and we actually have, we have this conjunct here on line 2, and we have the conjunct to the left here on line 1. It's just we need to get rid of this letter P and the horseshoe. And we can do that here because, as you can see here, we have the letter P here on line 3, and it matches with the antecedent on line 1. So that's a simple case of using lines 1 and 3 and the rule of modus ponens to derive a horseshoe D. Okay? And so we got rid of those, right? And now, what we have to do is, again, we know we've reversed engineered the conclusion. We kind of know what we're looking for here. So now, we have to conjoin A horseshoe D and D horseshoe A. So that's lines 2 and 4 in conjunct. Okay. And then we know, using line 5 and the rule of equivalence, that this is just equal to A tribar D. And that would be the proof for this argument. The only thing to point out here is that, again, if your conclusion is a biconditional statement, it's a huge hint that you're going to probably have to use the rule of equivalence somewhere along the line here in this proof.